Good morning, everybody. My name is Chris Jones. I'm with the University of Arizona, Gila County Cooperative Extension, and welcome to this week's edition of the Garden and Country Extension webinar. We have got Michael Crimmins with us, and we're going to be talking about Rainlog, Arizona's Cooperative Rainfall Monitoring Network. Just a little bit about these webinars if you're new to our show. This is a weekly Zoom webinar. They are 60 minutes or less, Thursdays at 11 in Arizona. So if you're not in Arizona, adjust your time zone. And we feature a variety of horticultural and natural resources topics relevant to the environmental conditions and residential concerns of Gila County and anywhere else in the world that may be the same. And a recording of this and all the webinars will eventually get posted to extension.arizona.edu/Gila. I will put the YouTube playlists that these get posted to into the chat box, so you can grab that link and be able to see the recordings in a timely fashion. We typically get them back up within 1 to 7 days. And the University of Arizona is an equal opportunity affirmative action institution. And with that, that's my cue for us to do our affirmative action poll. So this here is a anonymous poll, and just please share a little bit about your age and gender and ethnic identity, and I can close that down in a few minutes. Just some important information I need to be able to report to report. Okay, so back to the slides here. Here's our agenda for today. We've got, I'm your moderator, Chris Jones. Today's topic is Rainlog, Arizona's Cooperative Rainfall Monitoring Network. Our speaker today is Michael Crimmins. He has about a half-hour PowerPoint presentation for us. We will continue with a question and answer discussion when he finishes, 15-20 minutes, and we'll wrap up by noon and end the call. So if you have any questions, put it into the Q&A, put it into the chat box, and I will feed those to Mike. And here's our presenter, Dr. Michael Crimmins, professor and extension specialist at climate science, Department of Environmental Science at University of Arizona. Got that stock photo of you there, Mike. And I think I need to update, might have to update that, you know.
It was a little more clean cut back then.
Okay, so that's it. And I will hand it over to you. How are you doing?
Great. Thanks, Chris. This is so fun to talk with you. Old friend and colleague in extension, and excited to be able to talk about Rainlog. So do you want me to go ahead and share?
Yeah, take over the slides and start her up.
Okay, great. Okay, good morning, everybody. Just a quick check, we can see the slide, Chris?
Yes, everything's good now.
Okay, so as Chris mentioned, we're going to talk about the Rainlog. And so the title of this presentation is Filling in the Gaps, Volunteer Observations to Improve Precipitation Monitoring Across Arizona. And so this is focusing on rainlog.org. I started my position in 2005, and right out of the gate, that first couple of months that I was in this position was kind of just trying to get my feet under me and figure out what I would focus on in my extension specialist role. And one of the things that came up at a lot of initial meetings was precipitation data. And that's kind of an obvious thing for those of us that live in Arizona. We're always talking about the weather, and we're always talking about whether it rained or not at different locations. So in 2005, we've had long-term monitoring networks across the state, and we'll talk a little bit about that, but they've never been quite at the density and at the resolution to really capture the real unique localized precipitation patterns that we have and that we all see. And so I partnered with Gary Woodard, who was at the, it's a project called SARA. It was a large National Science Foundation Science and Technology Center project that was rolling right about that time at 2005. And Gary had the same idea of what's the opportunities out there for engaging volunteers, simple backyard precipitation monitoring to try to fill in the gaps across the state. At the same time, there was another effort that was kind of rolling out across the country called CocoRAWS, and I'll talk a little bit about that as well. It's a national backyard monitoring program, and we were doing the same thing at the same time and didn't know about each other. We've discovered each other since, but we do have some kind of unique differences and unique characteristics and continue to have both those opportunities out there. So to this date, we have about 3,000 volunteers, and we're primarily an Arizona focused entity. So we're run out of University of Arizona. I direct it now. Gary has retired, but still involved with the program. And it's completely volunteer. We get a little bit of funding from donations. We get a little bit of support from Salt River Project and some other partners that help us keep the website going, but it's really based on volunteer observations. And the crux of it is it's an online system. So the rainlog.org website is, we hope, easy to use, and we've refined it over the years and continue to try to get feedback from users to make it more easy. And the idea is that we want to make it easy, if you've got a precipitation observation, to create an account and share that through an online mapping system. Then the data is stored so we can actually use it for research purposes, and anybody can actually use it for any purposes for planning into the future. Okay, so if you go to rainlog.org right now, you can make the same map. This is just a screen capture. And so this is pulling up, it's kind of zoomed in on Arizona. It's kind of cut off at the top there, right around Prescott. You see Phoenix, you can see Tucson with all of those observations. That's typically how a lot of these programs go, where there's a lot of people, we end up having a lot of observers come online. But you see there's a Rainlog observer in Miami, and there's I think 2 CocoRAWS observers, which is the other volunteer network in the Miami Globe area. So there aren't too many in Gila County. I know the Rainlogger up in Young is very, very faithful Rainlogger. There's great data that comes out of there. And then there's in Payson and Pine Top. So you can see that in this is actually the total precipitation from the monsoon start June 15th up through about 2 days ago when I was pulling this presentation together. And you can see the variety of observations that we're getting here. So the total is being displayed on the little flags there, and the colors are scaled to the amount of precipitation. And you really do see some pretty diverse numbers. And you can, what we really like about this system is that you can zoom in, you can zoom right in on the neighborhood scale. And so if you had several observers in a small area, you get to start to pick up some of these nuances. So why Rainlog? So it's really to help supplement and complement the existing official monitoring networks that we have. So the official monitoring networks would be the airports, which have been around for a long time, have long-term climate records that we use for climate change studies, climate research, and we can look for patterns and trends over time. But they're not everywhere, right? And so those airports are typically in lower elevation flat valleys, and we don't end up having as many observations in complex topography or at the top of the mountains or into lower valleys. We have NOAA cooperative observers, which are other long-term monitoring networks, and we are losing those observers because they've retired or have moved on. And so now those official networks are often at national parks or at ranger stations. So we don't end up having really kind of good, diverse precipitation observations in much of rural areas, and especially in wilderness areas where people don't live. So we need these observations because we have lots of spatial variability in precipitation. And as we're seeing right now, especially in the summer, the character of the precip this year has been really interesting in it being both heavy and widespread. So we're getting some more even patterns, but then in kind of a more typical monsoon, you'd end up having extremely isolated precipitation amounts in very small areas. And they will often occur in between the official observing networks. And we will never know what the precip totals were. We may see it on radar, but the radar can't really do a great job of estimating total precip on the ground. You actually need those gauges to help with that. We also know Arizona is home to many enthusiastic weather observers. When we started the program, in 2005, we immediately had about 100 people sign up in Tucson, which has got quite a few people, and it's continued to grow over the years. And our program is a bit different than some of the other existing programs on there. Ours has a really low bar to precipitation. I'm sorry, that was a Freudian slip there. Participation, not precipitation. Low bar to participation in that we don't require a standardized gauge, and we're really asking for you to report as much as you can. And so that makes the data a little bit more challenging to use, but we think that that's a good trade-off. And what I mean by that is formal programs like the NOAA National Weather Service Cooperative Observer Program. It's a standard gauge and really wants you to observe exactly at 7 a.m. every morning, 365 days a year, which is a really, it's a lot of effort and a lot of commitment to do. And we know that everybody can't do that. COCORAS is more volunteer-based standard gauge that's more inexpensive, still want training, and they really do want that formal participation in as many observations as they can, which really helps standardize the network and the data set. So that's, I think, really useful. We're kind of a different tier in the sense that if you have an existing home weather station or an existing rain gauge, we just ask you to report that so it goes in the database so we can then kind of detect what kinds of different gauges are out there, and then ask you to report ideally in the morning every day if you can. But if you can't, then as often as you can is helpful too. And so what we're doing now is we're bringing all of these networks together, NOAA, COCORAS, and Rainlog, to really try to help fill in the gaps. And I'll show you some of that effort that we're doing right now. So Rainlog is really our homegrown Arizona effort. And we hope it's got kind of that low bar to participation and easy to use. So we collect standard 7 a.m. to 7 a.m. daily precipitation total, and that's then reported to the previous day. So this is an old convention, and I think it's still a really useful convention for manual reporting. So this is something I don't think everybody realizes, but airports and home weather stations and anything that's got a tipping bucket rain gauge that's automatic typically reports the midnight to midnight total. But we don't ask people who have manual gauges to get up at midnight and read their gauges. And so that's been a convention that's been around for 100 years. The old NOAA Cooperative Observer Network still exists today. That's manual gauges is still read in the morning. So as you get up in the morning, you're reading that 24-hour total, and that 24-hour total is going to be different sometimes when there's overnight rainfall. So you got a midnight to midnight and a 7 a.m. to 7 a.m. that sometimes don't quite fully overlap, but it exists in the data. So manual networks like Rainlog looking for that morning report, and then we report it to the previous day. So the idea that most of the rain in that gauge has fallen in the previous 12 hours, the previous midnight to midnight period. And so sometimes there'll be a little bit of overlap, and you can sort that on the analysis later. We also, if you're interested, giving comments and anecdotal observations. I was looking at the Rainlog observation in Miami, and there's some really interesting reporting on when Miami flooded. So we knew when the rainfall total was, and then when the flooding event occurred. And sometimes we'll get reports on hail size, snow depth, local flooding, sometimes drought impacts. And that becomes really handy if you're just trying to pull a report together for your area. You get some of that anecdotal information. It also helps you sort out if there's maybe something challenging with the observation that doesn't maybe make sense. Maybe somebody was gone for a couple of days and said, you know what, this was the gauge total over 3 days rather than the 24-hour total. This is just an estimate. We can put that in the comments and see it later. Snow depth and melted liquid amount is it's not an issue for most of Arizona, but if you're up in the high country, getting frozen precipitation is harder to do with the rain gauge, but often what is done and what we ask people to do is to take whatever snow you have in a gauge, melt it down into liquid water accumulate. So you can tell us the depth, but then you can also tell us what it melts down to, and that's the liquid amount, and that's what gets reported conventionally across all climate reporting for wintertime precipitation is melted liquid equivalent. And then we built the system too with flexible reporting. Again, knowing that if people are volunteers, they can't necessarily do this every morning, 365 days a year for 30 years. If you achieve that, that's wonderful. Your record is golden and is really easy to use. If you can't, that's pretty normal as well. So what we'll often see with Rainlog reporters is, and I'll show you the data matrix, is that you can report just the daily total you're seeing in that and just attach the date. But we also have a grid matrix where it shows you the whole month. And you can, sometimes people will only report on days that it rains and then come back at the end of the month and then verify that the rest of those days were zeros. That helps us because complete records are easier to use if we know days that it didn't rain and days that it did rain. Some people only report days that it did rain, and we just have to assume that it didn't rain on those days, but we're not often sure. So they become missing data, a little more challenging to use. But again, that flexible reporting. We send you a reminder email at the end of the month once you log up that gives you a report back, what you reported, gives you a chance to make any edits to it and commit it in the database. And we, in the past, have had an Android app and an iPhone app, but the technology has changed so much that our apps are out of date, and they got kicked off of both of those stores. So we're trying to raise some money to redevelop those and make it easier to do on your phone. Right now, you can actually still access the site through a phone browser, and it works pretty well, and you can enter the data. It's not ideal, it's not perfectly optimized, but the idea is that we're gonna get both Android and iPhone apps in development in the next year or two. Okay, so I zoomed in here. This is the monsoon total, June 15th through August 8th. And it's zoomed in here on more, centered right on globe there. So that's that rain logger observation, about 4.5 inches. You can see what the variability is across Phoenix, and you can see some of the surrounding observations as well. So if you go to the site and you change your date, you can look at the previous date or a date range or the monthly total on the right there. And then if you click on any one of these flags, it will pull up a little dialog box that will show you the cumulative total precipitation, which is that red line, and the daily observations for the current calendar year. Gives you a sense then of the total year to date, and then the latitude longitude of that. And then if you click on that that flag, the title on the top, that 2021 precipitation in inches, click to open, it will pop up a new page. And this is publicly available for everyone, right? So if you go to the site now, you can really take a look at what's going on at particular individual locations. So then it pulls up the calendar view of all the observations. See, this is really nice, complete record here. Lots of zeros when it was dry, a couple of traces, and then now the precip has picked up since July. And then there's those comments at the bottom there. So it gives us a sense of, people were seeing rain and snow sometimes, sometimes fog. There's a report of the fire and smoke that were occurring there. I mean, that when we go back in, we can go in the database and we can look at these records, and it becomes really helpful if you're trying to pull together a report or do a research project. You can go back and actually see some of the other anecdotal things that were going on with the precip observations. I've really found this handy and really appreciate that information. You can also click on the multiple year chart here to go another level deeper. And it gives you an interactive dialogue here where you can then, this particular rain logger has data all the way back to 2007. And it automatically puts on the last 5 years, but you could turn those on and off and put on different selections of years. So you want to compare 2019 to this previous year, you could do that by just turning those two on, or a different assemblage of those years. And it gives you a sense then of what the characteristic climate has been as far as cumulative precipitation for these particular years. Okay, and then this is on the techie side. If any of you are into this, this is actually how you get the data out. This is something we've developed recently, and it's been really handy because it's made us be able to share the data easier and do research projects with it, and then have other people be able to reuse the data. But this is just a way of having your computer talk to the database directly without going through the website. And so we're also working on a way of connecting, if you wanted to say, have your home weather station talk directly to Rainlog and dump its data, we're working through this system as well. And that's a bit in the future, but that's a possibility as well. Okay, and I just want to give you a sense of some of the things that we've seen with the data. So the Tucson kind of core has the longest record of Rainlog data. When we started in 2005, it really started in Tucson. It's kind of grown across the state. And so we've been able to look at this a little bit more closely. And we did an analysis where we're looking back in July of 2018. And really what I'm really interested in is like how small and isolated are some of these extreme precipitation events, because I think there's a lot that we're missing. We can't see it because we don't have the density of the observations. And so Tucson's kind of an example here where we can look at it. So this is a run of days in 2018, which ended up being a fairly wet monsoon season here in Southeast Arizona. But the little X's there are rain log reports with no precipitation, so they're zeros. And I've got the airport there as the large number as we go across this grid. So it starts on July 3rd and it ends on July 14th. And so this was just sort of a comic strip time series here of the pattern of precipitation we saw across Tucson. And what we see here in Tucson, and I think it's probably the same up in Globe and Miami, is that you've got one official weather station, and that's the one that gets reporting for the region. So in Tucson, it's the airport, and the airport is on the south side of town. And it's actually in kind of the drier spot of the whole region. And so we track the monsoon we get the Tucson airport as the total representing the monsoon going forward. And we know that there's all sorts of variability across town. And so we've been able to look at this a little more closely. So the little dots when they show up are precip observations. So you can see on the 3rd and then the 4th, not much going on. The airport was 0. The 5th, the airport reported about 1300ths of an inch. And then across Tucson, we started to see more of those observations light up. So it was not only hitting the airport, was hitting parts of town as well. The 6th, 0, a couple of rain loggers saw some really isolated amounts. The 7th, it got a little weirder, where you're seeing sort of a more distributed pattern, some heavier amounts in the middle part of town. It was only a trace at the airport. And then it gets really interesting on the 8th. This is up in Oro Valley. The Oro Valley got hit with a very, very heavy thunderstorm and it missed the airport, right? So already we're starting to see the local official record diverge from what people are experiencing across the metro area. And this could happen in any community in Arizona with having one observation, not having multiple. And then the opposite day, the next day, the opposite happened, where the airport got struck with over an inch, but the rest of the town didn't. So it was an isolated event that kind of moved around town, and the record got back together, but they were offset by a day. And then the 10th became interesting again, is that Oro Valley got hit again with another inch event, but then also the east side of Tucson and the airport was a little bit out of sync. And then it kind of plays out towards the bottom, where you're kind of coming and going with the airport capturing its local observation representing all of Tucson, and Tucson seeing something different. And again, any community could see this. And if you had, more than a couple of rain loggers, even 5 could help really tell a different story than the one observation. This particular event, that Oro Valley kind of bullseye, ended up causing a fairly large impact as well. And we didn't see it in the airport data because the airport was too far away from it. But up in Oro Valley, one of those subsequent days ended up having localized over 3-inch precipitation amounts. And it was right along I-10. And it flooded out I-10, and it flooded out the railroad tracks there that go between Tucson and Phoenix, and it caused a derailment. So this is, I think, really useful if you're trying to do anything related to climate planning, climate research, and historical stuff. If you're kind of working in a municipality, is that having these additional data points can pinpoint, if you had an impact in the past, but if you didn't have any rainfall data, you wouldn't be sure exactly what actually happened with it. The Rainlog data in this case actually become perfect forensic evidence to be able to piece together what happened with this particular event. Okay, so beyond research stuff that it's not, the data set in Rainlog is not just it's not my personal ploy to collect data for me to use it. It's a collaborative community thing where the data can come in and go back out for whatever the purposes are. And so we're actively using it for drought and climate monitoring. I'm on the Governor's Drought Task Force, and I'll show you a tool that I built that uses Rainlog data as well as the other networks to really keep track of, on a daily basis, how unusual is the rainfall we're seeing over different periods of time. And that has been useful, and I've seen it showing up in resource management reports. So NRCS using it, Forest Service, BLM. It's also used in water harvesting planning, and we're trying to more actively sort of integrate with water harvesting planning, is having a rain gauge at home. If you're doing water harvesting, either passive or active, you're also a water manager at that point. And you're a water manager in the sense that you need to know what the inputs are to manage the outputs of your water harvesting. So that becomes helpful. And it's the same for irrigation management. Having that precip observation at home becomes critical. It's been used in urban water quality studies down here. The rainfall data has been used in modeling to look at stormwater, and then how that stormwater turns into varying levels of water quality. Used in urban flood control. So looking at patterns across town to know when you got to go clean up storm debris. The Rainlog network can be helpful for that. And I think hands down, what it's used for most is just taunting your neighbors and friends with your epic rainfall totals or commiserating. And so there's lots of water cooler conversations. Hey, how much did you get? I saw in Rainlog this morning that your neighborhood got, what did you actually get? And I get a lot of emails and I get a lot of traffic around that. And that to me estimate. And that historical estimate is from a different data set. So you don't have to have a long-term data set to actually be able to participate in this effort. As long as you're collecting data and it's fairly complete over different time periods, got a couple missing days over 30 days, you'll still make it into this. And then it can help us understand like your precipitation total of 4 inches or 3 inches or 5 inches is exceptionally wet for the last 30 days, or it's kind of near average, or it's below average. That's what this effort is here. And let's see here. This is the rain logger here in near the globe area, who has a complete record here over the last 30 days. And this is, I think, really handy and helpful here. As I just started zooming in here, I can float over this particular location. And this person has observed 3.54 inches. The long-term estimate at this location for the past 30 days is about 2 inches. So it's about 1.3 inches above average for this time period, which would put it at a percentile rank. It's in almost the top 5% of all the time period of July 10th to August 8th for the last 120 years. So it gives you an estimate of like, oh, wow, it has been raining a lot. It's in the top 5. This is actually would be in the top 6 record wet conditions for the last 30 days of this location. And so it just helps put your rain log data in context and helps us for drought monitoring across the state. Okay, so how do I participate? Get a rain gauge and install it in your backyard. If you already have a rain gauge, you can go ahead and use it. If you're starting out, we recommend a couple different types of gauges. The wedge type gauge is the one we've used traditionally here in Arizona for a couple of reasons. It's super rugged. It'll last for years out in the Arizona sun, and it's inexpensive. It's about $15. You can find it at various online retailers. And it's got an interesting shape. It's wedge shaped. So small precipitation amounts fill up the gauge faster. So the gradations on it are nonlinear. And as you get to the top, or it gets the top of the gauge, as it gets more full, they get closer together. So it's really easy to be able to see small precipitation amounts. So we think it's really handy. The downside is it's that wedge shape, you get bugs in it and it's hard to clean out. So it takes a little more effort on that. Doesn't work great with snow either. So if you're in a snowy spot, you might look at a different gauge. This other gauge here is a standard CocoRes gauge, is a standard 4-inch gauge. It's about twice as expensive, different design. It's got a funnel overflow. So the inner tube there has a 1-inch total on it. So it's calibrated as it fills up, it gets to 1 inch. So you can read it, but if it fills up over an inch, it overflows. So then you've got to do this where you look at the total in the inner tube, you write that down, and then you dump the overflow into the inner tube and then add that to the other. So it's kind of a multi-step hands-on process. It does work well for snow because you can take the top funnel off and the inner tube out and just leave it out. And then that can be brought in to melt and then poured into the inner graduated cylinder on the inside. So those are kind of 2 options there. So getting that rain gauge, you create an account, and I'll show you how to do that real quick. Log your observations each morning, ideally, or on rain days, filling in the zeros at the end of each month. Okay, and this is a little bit grainy, but this just gives you a real quick idea of where to put a gauge. So the best practice on putting a gauge in, this is really hard to do for most people, is you put a post about 3 to 5 feet high, you bevel the top of the post, you install your gauge above the top of the post to keep water from splashing into it. So it's just to try to get it up in the air without having anything splash into it. And then you want to keep it away from overhead power lines, trees, and anything that might cause either enhance the wind or cause the wind to die down or to shade the gauge in any way, or to cause water to drip into it or keep water from coming into it. So it's just kind of open sky. It's hard in most yards. And so putting it on a fence is okay. It's not ideal. And it's actually what I have in my yard because I don't have an open spot, but putting it on a fence where it sticks up above the fence on the edge of the yard can be okay as long as those other things are the overhead open sky is met. And the reason that fences aren't great is that fences can cause turbulence in the wind and can cause anything. What you're trying to do is minimize the effect of wind of either wind causing drops to blow into the gauge, which is overcatch, or out of the gauge, which is undercatch. And so there's an ideal catch. Rain gauges are, in monitoring precip, interestingly enough, is very, very difficult to do. The highest quality gauges are actually buried in the ground. And so they've got an open area and the gauge is below ground. And so there's only a couple of those probably in the whole United States, and they're for research purposes. Okay, so create an account. You go to rainlog.org. You go right to this, this link here at the bottom. And if you get into this, it's just going to ask you for a username and password and then some additional information. We don't store anything other than your account name, which will be your email. It'll be associated with your email. Your password is encrypted, and then your location for every gauge in lat long. We don't store anything about your actual address. It's just a lat and long. And then once your account is created, you log back in, and then what you're going to want to do is add a gauge, because you can create an account and not have a gauge, and Rainlog won't do much for you. At that point, you can actually set up a notification if you want. And the notification button at just to the left there, you can set up a service where it will email you if other rain loggers in your area observe rain. So it's kind of a passive way of participating in Rainlog, being notified of other people. If there aren't any rain loggers in your neighborhood, though, you won't get any notifications. Okay, so to add your gauge, click on data, click on view edit gauges, and it's going to open up this page. And I already had a gauge here associated with my account. The plus button on the right there will open up the dialog box to actually add gauge information. So when you get to that, you're going to name your gauge. You're going to tell us a little bit about the brand and the model if you know it. You know, if it's a true check or it's a home weather station. This becomes really useful for us when we go back and analyze the data later. We can put data into different bins and try to analyze it in different ways. This is just for you, additional notes or description about the location, anything that you might want to store with it. And then you can use the map to drag a pin and drop it to your location, or you can have it looked up by address, or if you already know the lat long, you can add it here too. Then you submit, and that will store your gauge underneath your gauge dashboard. And then when you have that, what'll happen when you come back to the site, you want to put in observations. You go, today's entry is just a single form. I like to use the daily entries, which shows you the whole month here. And that will be associated. You can have multiple gauges as well here. So this little Casa de Crimens here at the top here tab, if I had another gauge with a different name, they'd show up across here. So if I had multiple gauges, I could add observations for all of them from the single page. If you have one gauge, only one's going to show up. And in here, you're going to enter your precipitation observations. You can change the observing time if it was earlier or later. And then what you're going to want to always do is make sure that you click the check marks next to the observations that you want to commit to the database. So this allows you to add an observation, remove an observation, but it's really critical. They won't go in the database unless there's this checkboxes are clicked next to it. And you can, if you made a mistake and you want to go back later, you can always do that and change your observations later. And another added sort of flexibility with this is that in the upper right there, it says August 2021. You can go back as far as you want. If you have rain gauge data that you'd like to see get in the system, you can go back in and add it back. We've had somebody go back in and add data back to the 70s because they had daily observations. And that's handy because you can go back and create a map then and use that data for other purposes. Okay, so what's next? So we are continually trying to enhance the website based on your feedback. We're working on that iPhone and Android app. We had a proposal a couple of years ago to try to implement a rainwater harvesting decision support tool that'd be a part of this. So you could go into Rainlog, and based on nearby Rainlog observations, you could enter roof area and it would give you some yield estimates. And so we're still going to try to push on that because I think there's some really cool stuff we could do on that. Because again, Rainlog can be part of your water management toolbox. One thing I'd like to do is develop more kind of community-based precipitation and drought dashboards. Got a lot of these statewide tools, but if there's interest and you've got enough Rainlog observers in a community, you know, we could work together to set up something that was just focused on your community that would be able to bring in that data and other data just to see how precipitation and other climate variables are sort of varying on a seasonal or longer basis in those locations. And then we're also trying to inform some other gridded climate products that are showing up in national type scale drought monitoring. So Rainlog is an available data source. We have an easy way to get the data in and out of it now. And so we're trying to help with producing some more monitoring products. There's a really deep dive if you're into writing or reading technical papers. We wrote this paper up just kind of detailing the history and some first things that we saw in the database and what we think Rainlog is really useful for here in the Southwest. And this is an open source journal, so it won't cost you anything or need library access. So if you want to check this out, I can send you that link. And that's all I have. And I'm really happy to field any questions if anybody has any at this point.
Well, thank you very much, Mike. I saw this several years ago and good to see it again. And real happy we have somebody in Miami working on it. And hopefully we can inspire some more people here in Gila County to participate.
Yeah, absolutely.
It often seems like Miami gets more rain than Globe.
This is the way to find out.
and well, you know, by these floods, unfortunately, we see the proof. But that was interesting seeing how the storms were up there in Oro Valley, and I wonder if that's a pattern.
Yeah, I know, and that's exactly the
wetter
kind of,
typically.
right? Well, that's the question that we can now try to answer is: are there locations in Tucson that have sort of favorable patterns? And I think what we're seeing initially in looking at some of the data is some summers, some areas just get walloped repeatedly. But on average, if you average out over a lot of years, everybody evenly gets what they get based on elevation. So it's kind of interesting to see that.
Now, a lot of years is 10 or what?
Right now we've got about 18 in Rainlog, which is pretty good, you know, from climate. Ideally we'd want to see like 30, 40, 50.
Okay.
You know, so, you know, some of these observers have been hanging in there for a long time. And again, that's a huge commitment.
Yeah.
I don't think I've done a single thing in my life for more than a couple of years, except for this job. So, you know, that's a lot.
Yeah. Well, now that you're a papa, that's going to be a long time too.
That's right. Well, that's a good point. Thank you, Chris. You just pointed that out. That's probably the thing that I've committed to the most.
Yeah. Hey, okay. So Steve asks, does Mojave County have any observers?
It's a really good question. Take a quick look here. So based on, I'm just on the Rainlog map right now, and just looking at the most recent day, there's a couple of observers. There's an observer in Kingman, Laughlin, and in Lake Havasu City, and I've seen those observers pretty consistently over time here. And if I look at the monthly total for July, sometimes more people will pop up. So yeah, there's a handful. There's about 5 observers in Kingman, and there's even one in Hackberry, which would be just outside of, that's just off of Hackberry Road.
Okay. All right. Well, good. Okay. So going over the Q&A, some of the questions are coming in here. One has asked, I would think you would want to shield from wind. Seems like you said to put it in open, not shielded from wind though. Is that correct?
Yeah. So the highest end weather stations for climate monitoring have a really sophisticated windshield. And so they're sited in these broad open areas. And then they've got this ring of flexible shields that cut down on wind that's like at a radius of about 10 feet around them. And so that is a pretty intense setup for any given yard. And you're trying to always dance the knife edge between too much wind exposure and too little, because too little will often mean that you've shielded the gauge from precipitation. So it's just trying to find that kind of optimal area where you want to have as much rainfall fall into the gauge where wind won't blow it out versus not having rainfall fall into it at all because you've shielded it somehow.
And as just the home standard for this, it's just like in an open area. And
it's in an open area and it's off the ground. And you know, in the middle of your yard, if you have that, that's the trouble is that the middle of the yard often has like my yard has a power line through it or a tree. And so to get to an open area, I had to go to the edge of the yard, which is along a fence. And so again, I think it's okay. And I've actually done some studies because I've got, so you can imagine I have multiple rain gauges in my yard and they're all over the place. They're all very close to each other. And so the wind effect is usually not more than like maybe 5%. Whereas you could imagine having a much larger impact on rainfall totals if it's, either getting dripped into by a roof edge or a power line, or if it's too close to a tree. When you've got those really heavy events, you'll see you'll see this on the ground in some of those heavy thunderstorms. You'll get kind of a dry area in certain parts of the yard that just don't quite get it because they're shielded by something.
Yeah. Okay. All right. So another question. I live in northern Gila County in the spring to early fall and in Phoenix for the rest of the year. Is it possible to enter 2 gauge locations?
Yes, that's exactly one of the things that we designed earlier, is that you can set up as many gauges as you want. And so as I showed in that slide there, the little add gauge plus, you could put one for your one location and the other for the other, and just report whenever you're at one of them.
You'll take what you can get.
Oh, absolutely. And again, that's our kind of strategy, which is different than other programs, because I think that the take what you can get, you get more interesting information for events, and we can use the other networks to kind of backfill and triangulate and those kinds of things.
Okay, good. And Susan's asking, how do you get started? I have a rain gauge 5+ feet and in a great location on our property. So you shared that, but
Yep.
Perhaps you could jump into the chat box and just put that rainlog.org. I think that's all it is, Susan.
Yep, rainlog.org. And I can, Chris, if it's possible too, I can give you this presentation, and or people can contact me directly and email me. Either way, we can give you the PDF of this presentation, and then it's got those screenshots, step by step, that tell you what to do. It's pretty straightforward. Once you get in there, you create your account, you have an account, then you go back, log in, and then you add your gauge, and that should walk you through pretty straightforward and easily. But you can always email me if you have questions. I'm typically talking with a couple rain loggers every morning over email based on questions.
I put that in wrong. I put rainlog edu. I'm sure it's rainlog.org, right?
Thank you. Yes, it is.
Yeah. Oh, well. Okay, more questions. Ken's asking, how does wind affect the rain gauge, the gauge capture? So back to kind of these issues. Example, no wind versus 30 miles an hour. Does it tend to increase or decrease the amount captured?
Typically, so wind typically promotes undercatch. And so a still day with rain falling straight down is an idealized condition. And that should be a true measurement of the precipitation depth that accumulates on the ground. Any kind of wind starts to change the number of drops that get into a gauge. And if it's erratic too, that's usually the biggest challenge of it. It's kind of pulsing and it gets to be really windy, as you can have moments where it's blowing very few of those drops into the gauge. And so typically most gauges have long-term systemic undercatch associated with them.
Okay, good. All right. Well, if you have more questions, please enter them in the chat or the Q&A. We have got the UA Climate Extension Specialist with us. We've been talking about Rainlog, but he can answer all kinds of questions about weather and climate, right, Mike?
I can try.
I'm putting him on the spot here.
That's right.
And if you've ever listened, you can even give a plug to for your podcast if this group hasn't heard about it.
We do have a monthly podcast where we talk about Arizona weather and climate. We usually talk about the last 30 days and what's happened across the state and the broader Southwest region. And we're deep into monsoon discussions right now. So if you want kind of inane banter around weather and climate in the Southwest, we're your place to go.
Well, and along that line, we were talking earlier, and you can show your screen or whatever you need to do, but we would say that last year's monsoon is the opposite of this year's monsoon. And there are weather patterns or whatever that sets us up for either of those. Can you discuss that with us and tell us what happened and what's going on? I know you can't tell us what will happen.
That's right.
What happened?
That's what happened. Yeah, I am trying to think of what the best way to do this at this moment is. I can show you I can show you, I'll show you a precipitation map for.
Go ahead and hit the share screen window.
Yeah, let me get that.
Okay.
Let me get that up here. Okay. Okay. Can you see the my webpage here?
Yeah, we've got.
Okay. Okay, great. Okay, so so as part of my program, I have a webpage where I pull together a lot of resources, and I'll just show you a precipitation map here. I got some monsoon precipitation maps, and so this is using gridded climate data. So it's not using a lot of the observations we talked about today. So it's a different effort. We're trying to bring all these things together over time. But on this page, you can look at recent precipitation totals for the monsoon season. So if we click on the total precipitation, it's going to give us a map here. And this is an interesting product because it's actually using radar data and a small assemblage of surface gauges. So I think that having rainlog observations with data sets like this together can tell you a much richer story. But what we see here is that we've had pretty expansive, widespread precipitation amounts across Arizona since June 15th that exceed 3 inches. And we're getting precipitation totals of 3 to 6 to 7 inches in the lower Colorado River Valley, which is not what you see every year. So this monsoon, in contrast to last year, has been just pretty epic, and different kinds of storms, different periods of storms, different length and duration. And I was just on a briefing call this morning with the Weather Service, and we're looking at another active period starting tonight through Sunday, which could bring more multi-day rounds of heavy precipitation. And so having that many kind of periods kind of stands out as being unusual. And if we look at this map right here, this gives you an idea of how unusual the precipitation is. So this is percent of average precipitation. So for the June 15th through, this is through August 10th period, if you're at kind of that 100 or that white band color there, that would be the average for this time period. We have almost no parts of Arizona are seeing below average precipitation, and it might be just small little pockets that have gotten unlucky between storms. But overall, most of the state is seeing above average precipitation, and there's quite a few areas that have seen 2 to 3 to 4 times as much precip as they would normally see through this time period. And then this plot kind of helps articulate that a little bit more. So this is the area of the state that's in these different categories. And so that white band there is near average, 75 to 125%. So the brown is below average, less than 75% of average, and that's just under 15% of the total land area of Arizona right now, where almost 30% of Arizona is at much above or 2 times their annual precip. So that's unusual. And we can kind of look at this in a different way. We can look at the whole Southwest. This is basically the same kind of plots, a different data set here. But what I can do is I can look at last year in contrast. We'll pull this up real quick. This has all of the monsoon seasons.
Wow.
Back to 1981. So if you really want to do a deep dive on monsoon variability, you can do that. But this is going to take us to the 2020 page. And we can look at these compared to each other. And so this is 2020 through the whole monsoon season. So this is through the end of September. So you can see there by the end of September, most all of the Southwest was below average. Some places were driest on record. For the second year in a row, was Flagstaff's driest on record, and nobody really did well. And this is the map through today. It's a completely different color part of the color ramp. And so, yeah, so you've got these back-to-back record dry to very wet. We're not quite to record wet year. I mean, we've still got another 6 weeks to round out the full monsoon season. And if it doesn't rain again anywhere for the next 6 weeks, we'll probably kind of glide into above average to maybe top third. If we get more events, we can start to, really go after some of the wettest monsoons on record. But Tucson proper had its wettest July on record last month, kind of crushing the old record. And what has caused all this is, I'm trying to think if I've got a good plot here that I can pull up, is showing you the position of the, basically the steering flow in the mid-levels of the atmosphere. This isn't quite a good one. And I'll do this real quickly, but I just want to give you a sense of.
While you're pulling it up, it just seems like there's not a real organized weather system the way this is happening. Maybe I'm not observing it right from my point of view, but there's just general moisture.
Yeah. So the monsoon season is it's really interesting in the sense that it doesn't really have much to it other than moisture. Like there's not, the weather features in a monsoon season are very subtle and weak and kind of ambiguous when you look at climate or weather maps. And what it is so this map right here is showing us the mid-level of the atmosphere. It's the 500 millibar height. It's about 15,000 feet in the atmosphere, and it's showing us the wind direction. And so the brown clotheslines give us a sense of different ISO lines. So you can think of this as a topographic map. So the low would be a valley, and the H here would be a high. And so air wants to flow from high to low, just as you would have water flow downhill. But the Coriolis force causes the air to flow clockwise around highs and counterclockwise around low. So it takes this long circuitous path with it. So these little flags here, which indicate wind direction and speed, give us a sense of where the wind is actually flowing. So what's interesting, as you're pointing out, Chris, here is if you look across the Southwest, you think of this as kind of a mesa, right? Like there's not much topographic relief. And that's right, there's not much topographic relief. There's not a high or low pressure system here. But there are these little subtle changes in wind direction that give us an indication that there's a little wiggle or like a little circulation or something like that. And those are everything. If the moisture is there, those little subtle changes in wind directions, speeding up, slowing down, create these crazy massive explosions of thunderstorms that kind of move all across the state. And it's also why the forecasting is so hard. Figuring out the position of a high or a low, models do that really, really well because they're big kind of constructed features that move pretty coherently through time. But down here in this kind of really murky, weak flow, finding and predicting where those little wiggles and swirls will go is really difficult, which is why, the monsoon is like 3 to 4 days at best in a given season. And we really didn't see any of this coming back in June, right? We had no idea that the monsoon, the Four Corners high would be in a great spot so early, which turned into epic heat wave for the Pacific Northwest, which is also what this map is showing right now, another heat wave. And we don't know what it's going to look like in 4 weeks from now. Most likely what will happen is that this high pressure system starts to lose steam and starts to kind of shrink and sag back south, which is normal as the sun angle gets lower in the northern hemisphere, and we'll start to move back in the westerlies, and it'll dry us out and we'll kind of move into fall. But again, who knows? A tropical storm in a couple weeks, 2, none, 3, I have no idea.
But like you say, that millibar, it's just like you said, a big plateau. It's just,
that's right. It's a plateau.
It's huge.
Forecasting plateaus is hard to do.
Well, thanks for sharing that. That was
a
curiosity of mine.
Absolutely.
And so before we get to the end of the hour here, a few more questions popped up. So sorry for everybody for eating up that time, but Steve's asking, everyone is worried about drinking water availability in northwestern Arizona, specifically Havasu. how does Rainlog play into drinking water, if at all?
Yeah, I don't know. I mean, I think that the drinking water, again, out of my lane, this could be a great seminar series, Chris, is I don't know if, and I'm thinking that's probably no. Surface precipitation probably doesn't connect with local drinking water, because most of Arizona drinking water, if it's from groundwater, it's old water. And it's and if it is connected to precip, it's usually the winter time. And it's usually, snowpack, surface water runoff, and that kind of stuff. So Rainlog is probably pretty ancillary to that right now. Again, having local precip, I think, is useful for a lot of things, and it could connect down the road with something like that.
But just different type of program with the groundwater.
That's right. Yep.
Yeah. Okay, so next question. What is the name of the podcast so we can subscribe?
Okay, great. I'll throw it in the
chat.
I will throw it in the chat.
And
go ahead. We're doing one this Friday of sort of a recap of the last 30 days, and that will be out the following week.
Would you send that one more time? Sometimes it only goes to the hosts when you send out a message.
Okay.
So click, make sure it's to everyone in the chat box. And while you're doing that, think about this question. Is there an effect of El Nino and La Nina on the monsoon?
Such a good question. Okay. So chat, let me see if this goes through, Chris.
Got it.
Okay, so the El Nino La Nina connection to the monsoon is murky, and it's been attacked in the research a couple of different times. And a colleague here at U of A, Dr. Chris Castro, he did some analysis that found that La Nina springs tended, and again, you have to have a La Nina present all the way into the beginning of the monsoon season, enhanced the monsoon circulation so that it showed up earlier and more robustly. And then what he found is that the ENSO effect rapidly diminished as you got into August and September. So it seemed to be like an early season type effect. And it could be even what happened this year. La Nina had faded by that point, so we're not really sure. Another study that I read that was actually using tree ring records found the opposite, which was El Nino winters and springs enhanced precipitation in northern Mexico and the Southwest. But I think what ends up happening is that they're talking about different parts of the season, and that later in the part of the monsoon, if you have an El Nino and you have warm water in the East Pacific, it tends to increase the frequency of tropical storms, and it tends to make the later part of the monsoon wet. The La Nina effect probably enhances the beginning of the season because it helps the Four Corners High set up. And then when you have a mixed signal, you probably have them fighting with each other. So that's why I think we don't have really good forecasting using El Nino or La Nina with it right now.
They just, the way I've always taken your class is they're just two different phenomena, and that's why we're bimodal, and there isn't a good connection between the two.
Yeah, and they're so useful for winter, they're less useful for the summer.
Yeah, and speaking of that, how are we doing? Neutral, no,
it's good, it's really good. And so we're gonna start talking about this more, but a second La Nina winter seems most likely now, so which is a little disappointing coming out of this great monsoon, is that there's an increased chance of below average precip next winter already because La Nina looks like it's going to show up. It looks to be weak, and it may even be short. So maybe its impact on Western weather will be minimal, but I do think we already have to start thinking that, we're not going to be out of this long-term drought anytime soon.
Okay. Stick with us for just a moment. I'm going to close down the recording. So we've still got a couple more questions for you if you can hold on for me, please.
Absolutely.
Okay, let me get the slide up. So we want to thank Mike for his presentation. Thank you so much. Really enjoyed that. So our presenter here. And we have just enjoyed our Q&A discussion with Michael. Thank you so much for sharing your questions and so much information.
Thanks, Chris.
And I'm going to take a little break next week, taking a kid off to college. And so we'll be back on August 26th with Rich Johnson, my master gardener up in near Payson. And he's going to talk about how to start your winter garden. Here we are in July. It's like, how do you start your winter garden? So no, for all my gardeners, there's no time not to be thinking about gardening, right? And with that, I'm going to say thank you very much. Have a good day and see you next time. And